Okay. So correlation and regression, how it is different from your hypothesis testing? Hypothesis testing helped you to understand the criticality, whether the factor is critical or not. If it is critical, it means, it is more likely that is the root cause. Maybe a single root cause or maybe multiple root cause. Whether it is single or multiple and what kind of relationship a factor has got on your Y variable, this will answer. Correlation and regression will answer, right? And correlation will give you a correlation coefficient and regression will give you a mathematical equation. We call it the mathematical model, right? So first we'll see correlation. What is correlation analysis and Pearson correlation coefficient? How to interpret a correlation analysis, and then we'll see some case studies also. Similarly, in regression, we'll see what is regression and some terminology related to regression and regression models, because there are linear model, non-linear model, or curvilinear model, and then again some case studies. And before going for correlation and regression, I strongly suggest all of you to plot a diagram called scatter diagram. Scatter diagram is one of the 7 QC tool. Scatter diagram is one of the 7 QC tool which you can use to study the relationship between two continuous variables. For example, the relationship between height and weight, the relationship between the amount of food you consume and then amount of weight you put on, right? And the speed versus mileage, the material removal rate and the surface finish, the concentration of the chemical materials and then the strength of the material, right? And time consumed and then the yield that is coming out of the process. So in all the cases, you can easily notice the variables are continuous variable. X variable also continuous, Y variable also continuous. In any scatter diagram, X variable will be represented in the horizontal line. This horizontal line will represent X variable, which is otherwise called as predictor variable. And Y variable will be represented in the vertical axis, that will be called as response variable. And we are interested in understanding the relationship a predictor has on your response. The relationship a predictor variable has on your response variable. Look at this first scatter diagram. I keep on increasing the X variable and Y variable is fluctuating like this. Now, when you notice this kind of pattern, do you think a relationship exists between X and Y?
No.
No, right? It looks like, the stars in the sky. Completely points are scattered. So X is not actually influencing the Y. That is what you could make out if the points are completely scattered. It simply means there is no relationship between X variable and Y variable, right? So under such situation, we call it, no correlation. And the formula is also designed because when you want to look at the points and then make a decision, you have to rely on your eyes. But if you wanted to have some formula, and a statistical formula is available, which is called Pearson correlation coefficient. When the points are completely scattered, R will approach 0. So I'll also show you the formula. Now coming to the next thing, this diagram, first diagram. Look here, I keep on increasing the X. What happens to the Y? Y also keeps on increasing. And moreover, the points are perfectly lying on a straight line. That means, what is your understanding now? Do you think the X and Y has some relationship?
Yes.
Definitely. If you want to increase the Y, what you need to do is, you need to increase the X.
So a relation, positively correlated.
Very good. And the relationship is positive because increase in X causes increase in Y.
The Y.
Yeah, increase in X causes increase in Y. So this is called a positive correlation. This is called strong because all the points lie on a perfect straight line. When the correlation is strong, the equation you derive will have more meaning. When the correlation is strong, then the equation, when you derive the equation of this, that will have more meaning, that will take you close to reality. On the other hand, picture number 2 or the graph number 2, the relationship is strong, strong but negative. So the Pearson correlation coefficient formula is designed in such a way that when the points are completely scattered, it will approach 0. When the points follow a straight line pattern, it will approach 1. the maximum possible value is +1 or -1. See here, I am getting maximum +1 because all the points are in perfect straight line. Hope it is clear to all of you. And so what we understood is R can vary between +1 and -1. And in between there is 0. 0 means no correlation. 1 means perfect correlation. Perfect correlation means a straight line, a beautiful straight line you can see. So 0 to 0.4 is called weak correlation. 0.4 to 0.7 is called moderate correlation. 0.7 to 1 is called strong correlation. You have this classification on the positive side as well as on the negative scale. This is the formula all of you need to understand to calculate the R value, which is Pearson correlation coefficient. N is the number of data you have. X bar is the average of X value. Y bar is the average of Y value. S is the average of the S is the standard deviation. You calculate standard deviation for X value as well as calculate standard deviation for Y value. And this is how R is obtained. And now I am showing a scatter diagram. Look here. On the X-axis, calories consumed. You consume more calories, you will gain more weight. That is what the points are showing. And now look at the blue color points. Don't look at the red color line. The red color line is called regression line. We'll talk about it later. Now look at the blue color line. Can you comment on the nature of relationship? Is it strong, positive, or medium, or what it is? Come on, guys. What is the relationship? Is it falling under weak or falling under moderate or falling under strong?
It is moderate, sir. Moderate.
Moderate. So that is why, a formula is required. So Gokul said moderate. All of you agree with moderate?
Yes.
Strong also.
Yeah. Only to resolve this disagreement, we need a formula. Once you use the formula, all of you will be able to easily conclude the relationship is strong. So strong means the points are too close to the straight line. The points are too close to the straight line. We are interested in understanding the equation of the line, which is called the regression equation. So this is strong positive correlation. And now first diagram. Tell me, look at this curve and tell me what kind of relationship it is.
Strong negative relation.
That is confirmed with the R value. See here, a negative value comes in R. At the same time, it is close to 1.
Yeah.
Second one, this one, what is the relationship?
Strong positive correlation.
Strong.
You can even say very strong, right? And now what is this relationship?
This is
Scattered.
positively related but very weakly.
Weak positive. And now what do you understand here?
There is no relation. There is no
relation. Avik Ghosh statement is wrong. You can't say no relation. You can only say no correlation.
Correlation.
There is no correlation.
No correlation because correlation measures strength of linear relationship. Linear relationship is absent, but a curvilinear relationship is present. Do you understand?
Yes.
The relationship is parabolic. You call it parabolic, you call it curvilinear, or you call it quadratic, right? So the Pearson correlation coefficient doesn't measure anything about curvilinearity. It measures only the strength of linearity. When R is 0, you should not say no relationship. You have to say only no correlation. If you want to say no relationship, then your graph should look like this. How? Here, what can you say here? You can say no correlation. You can also say no relation. But here you can only say no correlation because still there is a relation. All of you are with me?
Yes.
Very good.
Yes, sir.
Yes.
So now we are going to see an example. Imagine you are a dietitian. You are advising a patient. A patient wants to lose weight. And so you, before giving the advice, do you think as a doctor, is it important to study how his body is behaving? Come on, guys. Yes or no?
Yes.
You are a doctor.
Yes,
a
very
patient
much.
has come to you. He is asking, doctor, I want to reduce weight. 10 kg weight I want to drop because it's my goal. Within next 2 months, I want to reduce. So it's very important you study the behavior of the body. If you don't study, straight away, if you give some medicine, in my opinion, you are not a doctor at all. You are only money-making machine. Am I correct? So as a doctor, you are studying How are you studying? You are advising the person to consume a specified amount of calories every single day for 1 week. First week, 1500 calories and no weight gain is observed. Next week, 2000 calories. Next week, 3400 calories. Likewise, a study is conducted for 10 or 12 weeks. Now you have a data. Now you don't, as a doctor, you have a data about the behavior of the patient's the body behavior, right? And so with this thing, you are going to understand what kind of relationship the calories consumption has got on the weight gain. And now see here, this is the graph. Now, as a dietitian, what do you understand looking at the graph? Is there a correlation? Is there a correlation?
Positive correlation. Yeah,
Positive
correlation.
correlation. Is there a relation? Yes, there is a relation.
Yes, there is a relation.
There is a relation. That means, as a doctor, if you advise him to control the calories, the patient will be able to control the weight gain. Am I right? If you advise the patient to control the calories, the patient will definitely be able to control the weight gain. So now you have the R value. Look at the R value. R value is how much? 0.97. Now tell me, can you also comment on the strength of the relationship? It is strong, weak, or very strong? Very strong. That means if you are going to give an advice to the patient to control the calorie consumption, for sure he is going to get the result. Am I correct? Yes or no?
Yes.
For sure he is going to get the result because the R is very strong. That is confirmed with the p-value what you learned, isn't it? All of you learned the p-value. What is p-value? The amount estimate of type 1 error. When you are actually advising the patient, what is the amount of risk you are running? It is showing 0, but p-value can never be 0. Computer has limitation. It is rounded and then it is saying 0, but actually there is some value. But in my opinion, it is definitely less than 5%. Definitely less than 5% means 95% I am confident that when the patient controls the calories, he can reduce weight or he can gain weight, whatever he wants, right? And also one more thing, I want you to calculate R square also. R square is called coefficient of determination. 0.97 when I square, I am getting 0.94. This 0.94 simply means this factor, calories consumption, is responsible for 94% of the variations you have observed in the weight gain. That means this weight gain is controlled by the calorie consumption to the extent of 94%. Now tell me, the calorie consumption is really a strong influencer? Yes or no? Very, very strong influencer.
Strong influencer.
It's a strong influencer and it's a single influencer. Do you get my point? Since it has come to 94%, it is the single influencer. This particular patient's body weight is increasing or decreasing only because of the calorie consumption. All other factors are working very fine. Like his sleeping pattern and then everything, everything is perfectly all right. And this particular patient is increasing the weight or decreasing the weight mainly because of the changes in the calorie consumption. That means now the solution can be offered. Please note, we are able to treat even a patient as a medical doctor now. We are not actually physicians. We are not actually the domain expert, but still with the statistics, we are able to work better along with the domain expert. Even you can guide the medical doctor, to come out with the proper treatment to his patient with the help of your statistical knowledge. This is the beauty of statistics, right? And that's why I always say domain knowledge plus statistical knowledge, will definitely lead you towards success. And if you also make use of the common sense, and definitely it will be a super success. All right. So I think this is very clear now. Now, one more example. Again, some more data. Please note, all of you don't get afraid of seeing all the words written here. For me, it is only number. You also bring number from your domain. And see here, something is written. One number is is amount of a chemical that is present. And other number is it talks about the surface finish obtained or the quality obtained, quality of the casting. It's called the porosity. It's called hydrogen content. So this is X variable. This is Y variable. And the experts, the domain experts, the metallurgy expert, they are telling that if the hydrogen content is out of no, if the hydrogen content is more, porosity will increase. Porosity means there will be holes inside your solid metal. Presence of holes inside solid metal will reduce its strength. So this is called porosity problem. So since the experts are doubting that hydrogen content is influencing the porosity, you are studying. Studying means you change the hydrogen content and noted the porosity. Now a graph is drawn. The graph is scatter diagram, and looking at the blue color dot, what kind of relationship it is? Strong, weak, or moderate? Moderate. That is confirmed with the R value. See here, R value is 0.625. And that is again confirmed with the P value. P value is 0.017. That means one of you tell me what is the estimated type 1 error here? What is the estimated type 1 error?
98%.
1.7%.
1.7%.
Then what is your confidence level?
98%. Almost 98%.
98.3. So always any statistical study should be concluded with the minimum 95% confidence level. That is why we always expect the P value to be less than 0.05. And coefficient of determination, R square, 0.625 into 0.625. That means 0.39 is the coefficient of determination, which is R square. That means 39% of the problems of porosity are caused by hydrogen content. 39% of the problems of porosity are caused by hydrogen content. Now tell me, this porosity, this hydrogen content, is it a single influencer or one of the influencer?
One of the influencer.
One of the influencer. That means you have to study further factors. All of you are with me? When you want to solve a particular problem in your company, you are thinking that this is the culprit, but this is not the culprit. Culprit is a group. So he is one of the culprit. You need to find out the remaining also, so that you can solve the problem to a good extent. Otherwise, you will end up only solving a small portion of the problem, not a major portion. What is required is you should be able to solve at least 80% of the problem. That means R square should be at always at least 0.8. Clear?
Yes,
Sir, no?
Yes, sir.
Yeah.
Yes, sir.
Always when you do a correlation, you must use a scatter diagram. Don't do correlation study without scatter diagram. Correlation study should be confirmed with the P value, because P value is the estimate of type 1 error. Never conclude the relationship is cause and effect just because correlation value is high. Because domain knowledge is one thing, statistical knowledge is other thing. What is much more important is common sense. If you lag in terms of common sense, statistically you may be correct, but practically you may be wrong. So that situation should not happen. So use statistics, use P value, but never forget to use the common sense. And Pearson correlation coefficient is very, very sensitive to outliers. Outliers means points which are far away from the average. So such points must be excluded while calculating Pearson correlation coefficient. So what is that we understood? Correlation helps you to predict linear relationship. Correlation coefficient ranges from -1 to +1. Pearson correlation coefficient is very sensitive to outliers, so exclude them. And significance of correlation must be confirmed with the P value. Strong correlation doesn't imply cause and effect. Do you understand all the points? Do you understand all the point?
Yes.
Can one of you tell me what is the meaning of last point? What is the meaning of last point?
We should not decide the major cause only by seeing the correlation coefficient. Some common sense needs to be applied to.
Very good.
Yes. Yes.
One example I will tell you. Imagine you are studying about the rainfall and the spreading of a disease. What is that you are studying? Rainfall
And spreading of
and spreading of the disease. You collected data for 3 months. The rainfall is gradually increasing and disease rate also gradually increasing. Does it mean the rainfall is causing the disease?
No.
But statistically your P value is low. Statistically your R square value is 90%. Can I conclude rainfall is causing the disease?
No.
Then what is causing the disease?
Maybe a virus, but that is
That is
may be a contribute.
that is
influencer, but
spreading
it is
more.
not the-
That is spreading more when during the rainy season, isn't it?
During the rainy season, yeah.
So the virus is causing the disease, not the rainfall. This is called common sense, isn't it? Now all of you understand the meaning of the statement?
Yes, sir.
Yes, sir. Got it.
Yeah.
Got it.
Now we are moving on to regression equation. What is regression equation? Expressing the the red color line in the form of a mathematical equation. You call it mathematical model. Mathematical model may be linear, mathematical model may be curvilinear. Curvilinear can be parabolic, curvilinear can be, cubical. Parabolic means quadratic. Quadratic means second degree equation. Cubic means third degree equation. Linear means first degree equation. First degree equation means x, your equation will not have x square and x cube. Your equation will only have x. Second degree equation means your equation will have x square and also x. Third degree equation means your equation will have x cube, will have x square, will also have x, right? And also a constant term. So now see here, an equation is derived. Weight gain equal to minus 754.6 plus 0.4631 calorie consumed. This is the equation representing the red color line. If you carefully look at the equation, this weight gain is nothing but your y variable. Am I right? This is your y variable. Calorie consumption is your
X variable.
x variable. And x variable has got a constant. I'm going to name this constant as m. And this is minus 754 is another constant. How many of you remember the equation y equal to mx plus c? All of you remember the equation? You have studied, no?
Yes, sir.
In
Yes.
10th standard, 11th standard. Now, what is this m? What is this m? M is the
Slope.
beautiful. M is the slope of the line. In order to determine the slope of the line, draw a horizontal and keep your protractor and you get your theta. And now how to get m? What is the formula? M equal to, what is this I am writing? You got m equal to tan theta. Am I right? Do you remember tan theta?
Yes, sir.
Yes, sir. Yes.
What is the formula for tan theta?
Sine by cos. Sine theta by cos theta.
Opposite by
Or opposite by,
adjacent.
yes.
Very good.
Opposite
All of
by
you are correct. Opposite by adjacent.
by adjacent.
Opposite, when I draw a triangle, the opposite is del x, the adjacent is del y. You take a scale. I think I have suggested you to buy a scale, right? And you can try this. Keep a scale and determine del x, determine del y. The del x by del y will give you 0.4631. Clear? Or otherwise, measure the angle and go for the tan theta. That will give you your m. And also, what is this c called? C is called the y-intercept. C is called y-intercept. That means when I extend the line, it will meet the y-axis at this point. It cuts the y-axis at this point. This point is below 0. So it is negative point. So that negative value is brought here, minus 754. Do you all understand? I have explained every element of the regression equation. Am I correct? Yes or no?
Yes, sir. Yes, sir.
Yes, sir.
How the C came, how the M came, everything I explained. This is called regression equation. And this 0.4631 is called, regression coefficient. The whole thing is called equation, regression equation. And this number is called regression coefficient. And this is constant term, otherwise y-intercept. This is your predictor, which is x. This is your response, which is y, your y. So regression can indicate the direction and size of relationship. Look at the regression equation, regression coefficient. When regression coefficient is positive, the relationship is positive, right? When regression coefficient is 0.4, it means if you increase the x variable by 1 unit, y variable will increase by 0.46 unit. Do you understand my point? I repeat the statement. When you increase the x variable by 1 unit, y variable will increase by 0.46 unit. Suppose y is your profit. You want to increase the profit. And now the solution is, with the regression coefficient. Increase the x to whatever level so that, accordingly, your y variable will increase. So sign of the coefficient indicates difference. The coefficient represents the change in response. And one more thing you all need to understand about in regression is residual. See here, the blue color line is the regression line. In order to determine the line, these are the data points, the red color one. But actually data points, none of the data lies on the blue color line except this one. Most of the other points are either above the line or below the line. So what are you doing here? You are making some assumption. You are committing some error. You are simply assuming that points are on the line, and then you find out the equation of the blue color line and then take all your decision. This is called the error. Why the error happens? Error happens because of the residual. So what is residual? The distance between the line and the particular point. See here, this point is 380. This point is dropped down, and we are making it lie on the line. The actual value is 380, but we are fitting the point on the line at 350. So the difference between 380 and 350, 30. 30 is the residual. This is the error. So what happened? All your decisions based on the regression line will now have some amount of error because of the residual. If the residual is very high, then the error on your decision will also be very high. Error means uncertainty. You decide based on the equation, but in reality that doesn't happen. If you increase the uncertainty to a great extent, then all your predictions will go wrong. If you minimize the uncertainty to a smaller value, then whatever you predict will start happening in real time. When you say your confidence level is 95%, it simply means the associated residual is low. So the difference between the observed value and the fitted value is called residual. You can have positive residual. When your point is above the line, the positive residual is 30. When the point is below the line, then the residual may be negative. For example, it's like this. All of you understand what is residual here? Yes?
Yes, sir.
So linear regression means the relationship is straight line. Curvilinear means quadratic or cubic. Quadratic means parabola. Cubic means up and down and again up and down. It goes like this. So it's a first degree equation. It's called model order 1. And parabolic is quadratic, model order 2. And the third one is cubic, model order 3. You see here x cube is participating. Here x squared is what. So what kind of terms should participate in your regression model? You will be able to decide by having a look on the scatter diagram. So now for the same problem, this is the same problem only. It's not new. I already taught you calorie consumption and weight gain. So I just simply feed the data in Minitab, and Minitab will throw away this equation. You can also calculate it manually. And those of you who are seriously interested in strengthening your statistical knowledge, please do practice whatever I'm teaching, right? I'm okay to share the data with you, and you can practice it. And this, whatever you understand using the regression equation, that is again confirmed with the p-value, because the p-value now tells that the error is less than 5%, very, very small compared to 5%, right? Compared to 0.05. When error is 0.05 or when estimate of type 1 error is 0.05, your confidence level is 95%, right? And then R square, look here, any regression equation will have a model summary. S is a function of residual. S is a function of residual. You want more residual or you want less residual? Come on, guys. You want more or less?
Less.
Less.
So make sure your regression model has a smaller S value, because S is standard deviation. Standard deviation is the problem, is the killer for all the problem, right? And R square, I want more. If R square more means the factor is, model is sufficient. The number of factors considered is sufficient to solve the problem. If there is one factor and the R square is very high, more than 80%, this is the strong influencer, right? This is a strong influencer. Who is the strong influencer in everyone's family? Husband is the strong influencer or wife is the strong influencer? No answer.
Complicated question, sir.
Probably wife, right? So that means, the R square value for the wife will be, ladies will be higher, right? So they are, any decision, anything happens in the family, it is mainly because of people who have higher R square value. Similarly, a factor having a higher R square value is responsible for the problem. That means you are driving your project in the right direction. You are attacking the right factor, right? You are not wasting resources. And another thing is, adjusted R square overcomes the limitation of the R square. These are all statistical formulas. Formulas are, designed by people like you and me. And someone has designed R square, and the other one has found a problem with that. So he developed adjusted R square. Adjusted R square is more accurate than R square. Like your Z score is more accurate than T square, adjusted R square is more accurate than R square. So which is good? Looking at R square is good, or looking at adjusted R square is good?
Adjusted R square.
Adjusted R square is good, right? So if you are able to understand any model summary, please look at the adjusted R square, not R square. And the predicted R square is when you have sufficient amount of data, sufficient amount of experimentation, right? And you can use the regression equation for predict new observation. For example, if the person consumes, let us say, 850 calories every single day. What is the calories he is going to consume? 850 calories. What is going to be his weight if he consumes 850 calories for, let's say, next 1 week or next 2 weeks? So if you substitute the value, for the calorie consumption in the weight gain, what will happen? You can predict without doing the experiment. You can predict. Have you seen many softwares, which will give, what will happen, in the computer itself? For example, how petrol is burnt inside an engine. People can now understand just by, running a simulation software, isn't it? These are all possible because, they have developed a regression model with the higher R square value, higher adjusted R square value, and importantly, higher predicted R square value. If the predicted R square value is higher, then, you can do simulation. What you can do? You can do simulation. Computer simulation is possible only when the predicted R square value is higher. Otherwise, you have to do experimentation. Now, similarly, for the other example we have seen, the regression equation is here, p-value is here, R square is here. Now tell me, is this R square is a strong influencer or a weak influencer, or is this the number of factors considered are sufficient or not sufficient?
Not sufficient, sir.
Yeah. If you optimize this factor, what percentage of problem might get solved? What percentage of problem might get solved? Come on, guys. What percentage of problem you will be able to solve by controlling this factor? If I control this factor, what percentage of
1.39%.
39% of the problem might get solved. To be very accurate, only 33.96% of the problem only will get solved. Because I know adjusted R square is better than R square, isn't it?
Yes.
So look at the adjusted R square. Now, with looking at the adjusted R square, what do you understand is the amount of hydrogen that is present in the molten metal is responsible for 34% of the porosity problem. Remaining 64% of the porosity is caused by some other factors. So your problem is not over. The game is not over. You have to study other factors to improve the quality of your product. Is that clear? So regression is a technique to generate an equation describing the statistical relationship that may exist between X and Y. As a member of the Six Sigma team, you can make use of the regression equation to investigate the suspected relationship a factor can have on a response variable. And if you build the regression equation in a good manner, you can use it as a prediction model so that simply by mere simulation, you can get to know what will happen in real time. Regression result can help you understand the direction, size, as well as statistical significance. Statistical significance means p-value. The regression coefficient estimate the change in response per unit change in the X variable. Regression can be used to model linear, quadratic, and cubic relationship. So that's all about correlation and regression. So this